Hello. So this is my final project demo video. I have four programs. First, let's go through the README. Yeah, so as you can see, I have four programs. I did four of the pre-select programs. Program A, B, or challenge A, B, D, and E. We have descriptions right below that and how to compile, as well as the make command, and as well as how to run. So now I'll show you here, let me bring it a little lower, the folder. As you can see, we also have two test files, test_a.txt and test_b.txt. So the way I want to do this is first I'm going to show you a program, explain the code, demo, explain the code, demo, explain the code, demo, explain the code, demo. So let's get started with challenge A. This one was done in C++. The goal of this challenge is just to move the zeros to the left. And I think it took me a minute to kind of come with a really efficient way to do it. I had a slower way originally, but the top method is just a read file. And then my algorithm is contained in this short move zeros method. And all it does is I think my big realization was that you don't need to store zeros once you know that there's zeros. So all this method does is iterate through the array and shift non-zero numbers to the left and treat zeros as empty areas. And then just count where you are with your non-zeros and then pick up from there after you've iterated through the whole array and make everything else zeros. So that's what the first for loop moves all the non-zero integers to the left, and then the second for loop fills in the rest of the array with zeros. Just keep track of it with this pointer variable. Then the main method is pretty simple. Just get the file name as an argument, read the file, then print out the inputted array, call the move zeros function, then print out the new array, and then print out the number of non-zero integers as the description showed. So let us demo. So fp_a as a program name, and then let's do test A. So it prints out the inputted array, which is this, and then shifts the zeros to the right. So you see it works pretty well. I can show you with test B too. I think there are much less zeros in that. Yeah, so it moves the 1 0 to the right, which is pretty straightforward. And I was really proud of how efficient I got that program. That was awesome. Okay, now fp_b.c. This one was coded in C, not C. Oh, sorry. This one was coded in C, not C++. I initialized an array, a counter as global variables. This one was a pretty straightforward program. You just have to go through the array and find if an index matches a value number and return that I. Otherwise, return that there was no matching index. So I read the file, pretty straightforward. I use fopen. I did not use system commands, unfortunately, because I think this is a little bit quicker and more clear to understand the purpose of the program. Yeah, but I just read the file and put it into this global variable array. And then I have a quick find point method, which is iterates through that array and checks if the value matches the index. And if it does, it returns the index I. And if it doesn't, it returns -1. And this main method is also very simple. Just taking a file name from the arguments and check to make sure that it was used correctly, and then read the file with the file name that was inputted, run find point, which just iterates through the method, and store that return value. If the return value is not -1, print out the return value and return it. Otherwise, if it was -1, then just return -1 and say there's no matching index. So let's do a quick demo. fp_b, test1, test A, sorry. There you go. So let me just cat test A so you believe me. Yeah, so as you can see, 0, 1, 2, 3, 4, obviously. That is the first index that matches I, which is the program's requirement. And then we can do, let's actually edit test. Yeah. I mean, we can do test B too. pretty straightforward. Matching number 7. And if you look up here, where we ran I'll just cat SB, yeah, you can see, so all the indexes are off by 1 until 7, because it's right after that 0, which bumps the indexes to the same as the number. Pretty straightforward. Okay, now the code for fp_d.cpp. This one was C++ again. Yeah, so read file is the same. Main method opens the same way as fp_a. Prints out the inputted array, and then here I have the algorithm, which is also, I was very proud of how efficient I got it. So what I did was, so the goal of this was to move all the even numbers to the left and all the odd numbers to the right. So what I did was, instead of iterating through the method 1,000 times, which is what I had originally, I had a pointer on the left and a pointer on the right. And so I said, while the pointer on the right does not cross the pointer on the left, while it's still greater, you iterate your left pointer until you hit an even number, or until you hit a odd number. So it iterates if it's even, and if it's an odd number, it stops. And you iterate the right pointer until it hits an even number, and then you just switch them. If the right pointer is greater than the left pointer. So that's just in case like it iterates past each other. Yeah, so it's a very straightforward program, but it took me a long time to kind of figure out an efficient way to do it, because first I just had for loops and a second array, and that was just not efficient and took up way more memory than needed, especially with bigger arrays. But yeah, and then it just prints out the new array and then returns success. So now let's demo, just clear. So fp_d test a.txt. So as you can see, 0 is an even number. All the even numbers 0, 2, 0, 6, 4, 0, 6, 0, 0, 4, 6 are all on the left, and then 7, 3, and 1 are on the right. So perfect. We can do test B as well. Yeah, so this one's a little more interesting, but 10, 2, 8, 4, 0, 6 all on the left, and then 5, 7, 3, 9, 1 all on the right. Works well, very efficient, super happy about that. Low runtime, low space complexity. Yeah, okay, and then last but not least, fp_f. This was also in C++. And the reason I chose these is because I really want to focus on like reducing time and space complexity, and so these really force my brain to kind of understand that and really think through the most efficient ways. But yeah, this is very similar at the top, at least, to the other programs. It just reads the file and then prints out the inputted array. And then here, these collection of for loops are what the algorithm is basically. But the point of this is to find 4 numbers that add up to become 0 in an array. So I really could not think of another way to do this except for iterating through each array, or iterating through the array 4 times. But it still isn't quite just iterating 4 times, because there are some interesting things. So as you see here, the first for loop, it's in I = 0, less than array size -3. I'll explain that in a second, I++. So it's basically iterating everywhere up until the last 3 parts of the array. And then this for loop does not start immediately at 0 like the other for loop, because it wouldn't make sense to add the first number to itself again. So this one starts at I+1 and goes till the last 2, goes till array size -2. This one starts at j+1, so you're not comparing the third number. And then this one starts at k+1. So you're never comparing the same number to each other, or adding the same number to each other. And that kind of reduces I know it's still 4 for loops, nested for loops, which isn't exactly time efficient, but it does reduce it a little bit. Yeah, and then I just add the input, or I add the array at I, j, k, and l indexes, see if it equals 0. And if it does, I record it and return and end the program. And if it doesn't, we continue to iterate. And if it goes through the entire iteration without finding anything, then it says no 4 numbers sum to 0 and returns 1 instead of 0. Yeah, so it's not ideally efficient. I really focused on trying to figure out an efficient way, and this is the fastest way I could come up with. So to demo, fp_f test A, Yeah, so there are 4 zeros here, so that was pretty easy for the program, and there are no negative numbers. Yeah, so that sums up to 0, and then I'll show you test B, which does not have anything that sums up to 0. And it prints no 4 numbers in this array sum to 0 because there are none, which is expected behavior. I hope you, and let me do date and PWD. Yeah, this has been my demo video. Thank you.